Hello and welcome to the lesson notes for 4-5. This section is about isosceles and equilateral triangles. I've gone ahead and made some notes and color coding on here to try to make this a video not quite so long and arduous for everybody. So let's read through these notes here. I have highlighted all the isosceles triangles in blue and all the equilateral triangles in red. So this says that two special types of triangles are isosceles triangles and equilateral triangles. An isosceles triangle is a triangle with at least two congruent sides. The base angles of an isosceles triangle are also congruent. So basically, if two sides of a triangle are congruent, then the angles opposite those sides are also congruent, and that works in the reverse. If two angles of a triangle are congruent to each other, then the sides opposite those angles are also congruent. So this says that an altitude drawn from the shorter base splits an isosceles triangle into two congruent triangles. An altitude is a segment that goes from a vertex perpendicular to the side across from that vertex. So this is an altitude drawn from vertex B perpendicular to side AC. And in an isosceles triangle, it splits the triangle into two congruent right triangles, which can be very handy because we know a lot of things that we can do with right triangles, and we're going to learn a whole lot more. So a little bit about equilateral triangles. There are triangles that have three congruent sides and three congruent angles. Each angle measures 60 degrees because all three angles of any triangle sum up to 180, and 180 degrees divided by 1, 2, 3 congruent angles is 60 degrees. So here angle D is 60 degrees, angle E is 60 degrees, angle F is 60 degrees. We do not know what the side lengths are, but we do know that they are equal to each other. So this says that you can use the special properties of isosceles and equilateral triangles to find or prove different information about a given figure. So looking at the figure at the right, now they're talking about this figure with those two overlapping triangles. It says that you should be able to see that one of the triangles is equilateral, and the equilateral triangle is in red, and the other one is isosceles, and the isosceles triangle here is shown in blue. We know that this blue triangle is isosceles because the base angles A and E are congruent to each other, which tells us that side AB and side BE must also be congruent to each other. And then we know that this triangle CFG is equilateral because we can see that all three angles are congruent to each other. All right, so they give us a couple of practice problems here to look at. This says, what is the measure of angle A? Angle A. So if we're looking at this isosceles triangle, and we know that all three angles must add up to 180, and we know that angle A and angle E are congruent to each other, then we can simply add these up knowing that these are the same. We could simply call them x. We could say x plus 40 plus x equals 180. And they've sort of done that down here in the example, except that they just said measure of angle A. So measure of angle A plus 40 plus the measure of angle A. And they just said the measure of angle A again because we know that the measure of angle E is the same as the measure of angle A. So 2 times angle A, because they're the same, plus 40 equals 180. Then if you subtract 40 from both sides, you get 140, and then simply divide that by 2. Honestly, if I were doing this in the classroom, I would say x plus 40, or 2x plus 40 equals 180. And is effectively what they've done here. Just instead of saying x, they've said the measure of angle A. Okay? So there we're able to find out that the measure of angle A is 70. So this angle is 70 and this angle is 70. So then it wants to know what is the measure of FC. This says that triangle CFG is equilateral because it has 3 congruent angles. And it says that segment CG is 4 because it's 2 plus 2. And they give you these two segments here that make up CG, 2 plus 2. So if CG is 4, then FG is also 4. Oops. And CF is also 4. So all three of those sides are equal, so we know that FC is 4. They've moved the triangles down here to the next page, which is extremely handy. This one wants to know what is the value of x. It's because x is a measure of an angle in an equilateral triangle. We know that each of those angles is 60 degrees, so x is 60. Then it wants to know the value of y. So now we are looking at, now we are looking at this triangle right here. This little small triangle that is made up of the overlap of the red triangle and the blue triangle. We know that this angle is 60 degrees, and we learned previously that angle E is 70 degrees. So we can say 60 plus 70 plus y equals 180, and that's what they've done here. 60 plus 70 plus y is 180. 60 plus 70 is 130. 130. I could just type this, but where's the fun in that? Then you just subtract 130 from both sides, and that's how they got 50. Okay? So our exercises here, and again, I have color-coded these things for you. I hope you'll find that helpful. It says complete each statement and explain why it is true. Okay? So the measure of angle EAB. So EAB, I've put a green dot in here for angle EAB. Okay? This is an isosceles triangle because we can see that these two sides, AE and BE, are congruent to each other, which means that angle A and angle B must be congruent to each other. So if we just called that angle X, or X because they're the same, then we could start off here by saying X plus 40 equals 180. And this is very much like that problem on the other page. So here 2x. I'm going to go ahead and subtract 40 from both sides. So I'm going to say that 2x equals 140, and then simply divide by 2. So we get that x equals 70. And that is the measure of angle EAB. Okay? So look at it too. This is angle BCD. BCD is this one right here. It's congruent to what angle, which is congruent to angle DBC. Well, hopefully you can see that this is an equilateral triangle, not just because it's highlighted in red, but because all three of these segments are congruent. BC, congruent to CD, congruent to DB. That means that each of those angles are also congruent to each other, and they happen to be 60 degrees, okay? But what they're looking for here is the name of the angle. So we're looking for this angle D here. Name with 3 letters is BDC. So for number 2, we have angle BDC. Okay? I might need to draw some lines here to separate these. There's number 1. There's number 2. Okay, so looking at number 3, this says that FG is congruent to what? Which is congruent to DF. Well, you can see I have marked FG and DF with these orange slashes. And you can see that on that same triangle, there is a slash on DG. So that's all they're looking for here is segment DG. Okay? So looking at 4, 5, and 6, here we're looking for actual measurements. 4 wants the measure of angle ACB. ACB is this angle C right here in this equilateral triangle. And in equilateral triangles, each angle is 60 degrees. So we're going to show that this is, in fact, 60 degrees. Okay, and I'm going to put a 60 inside this angle. And that's going to help us in just a minute. I don't know if y'all can see that. Maybe I should change the text to black. Oops. So that you guys can see that a little bit better. That's not better, is it? Okay, I'll put it over here maybe. It's a little bit better, okay? All right, so the measure of angle DCE, and this is that same situation as we did up here on problem number 1, where if you have an isosceles triangle, you can simply put the same variable for both of the base angles. So I did up there for x, let's do the same thing down here. If I say that this is x and this is x, then I can start out here by saying x plus 50 equals 180. So 2x plus 50 equals 180. Subtracting 50, I then have that 2x equals 130. And then dividing both sides by 2, I'll get that x equals 65. So I find out that these angles are 65 degrees. So angle DCE equals 65 degrees. And I'll go ahead and put that in place here also, 65 degrees. Okay, number 6 wants the measure of angle BCD. BCD, I have put an orange dot in right here. And hopefully you can see that all 3 of these angles together make a straight line. All 3 of these angles together make a straight line. And a straight line is 180 degrees, okay? So I'm looking for this angle right here, and let's call it y, just to give it a variable, okay? So I'm going to call that y, then I can say 60 plus y plus 65 equals 180. 60 plus y plus 65 equals 180. And then we're just simplifying. 60 plus 65 is 125. So I have y plus 125 equals 180. And then subtracting 125 from both sides, and I get that y equals 55. 55. 180 minus 120 is 60, minus 5 more is 55. Good. So we get that this angle here is actually 55 degrees. Or angle BCD is 55 degrees. If I'm going too fast, please feel free to pause it, rewind it, watch it over and over again if you would like. We just have 3 more problems here. All right, I'm going to change colors back so that it has something other than black to type in. Let's go with this one. Okay. This says for 7 and 8 to find the value of x and y. So I've made a note here that's showing that these congruent curves on these 2 angles means that it's an isosceles triangle, which means that x and y are the same. Okay. So we know that y equals x in this problem because those 2 angles are the same. So if we said y plus x plus 110 equals 180, then I could substitute x in for y since they're equal to each other and say x plus 110 equals 180, and then simplify. 2x plus 110 equals 180. Oops, I should have scooted that over just a smidge, huh? I wonder if I can do that. Nope. I'll have to, there we go. 2x plus 110 equals 180. Okay, then I'm subtracting 110 from both sides, and I get that 2x equals 70. And then dividing both sides by 2, I get that x equals 35. And since y equals x, that means that y also equals 35. I'll type that out. Since y equals x, then y equals 35 also. All right. So on number 8, again, we have these congruent slashes on the 2 sides, and congruent marks on 2 sides means that it is an isosceles triangle, okay? If it's an isosceles triangle, then these base angles are equal to each other, okay? So I know that this is also an x. Now, the 115 and the x together make a straight line. These make a straight line, which means that 115 plus x must equal 180. So let's start with that. 115 plus x equals 180. It's a linear pair, and they are supplementary. So I can find x simply by subtracting. So if I subtract 110 from 180, or 115 from 180, 180 minus 110 would be 70. If we take away 5 more, then we get 65. So x is 65 degrees, and we can actually put that in our triangle here. That's 65. This one is 65. And because of that, we can use the triangle sum theorem to find angle y. Okay? So we can simply say now that, go back to text, we can say 65 plus y equals 180. Triangle sum theorem. 65 plus 65 is 130, plus that y equals 180, and then we're simply subtracting. So subtracting 130 from both sides, it gives us that y is 50. So now we know that this angle up here is 50. And you can check yourself here. Also, the exterior angle theorem, the 115 must equal the sum of the remote interiors, and 115 does in fact equal 50 plus 65. So it's just another reassurance that another one of our concepts that we have learned really does work. All right, number 9 says an exterior angle of an isosceles triangle has a measure of 140. And I've gone ahead and drawn this figure for you. An exterior angle of an isosceles triangle has a measure of 140. So if this is an isosceles triangle, then that tells me that these 2 sides are congruent, okay? So let's find 2 possible sets of measures for the angles of the triangle, okay? Now it doesn't have to be these 2 sides. It could be that one and this one that are congruent. So that's why it says 2 possible sets, okay? So let's work it as though these 2 are congruent first, okay? So that would mean that x must equal 40 because the x and the 140 make a linear pair. So if x is 40, then z would also be 40 because those are the base angles across from these congruent sides. And if x is 40 and z is 40, then 40 plus y would equal 180. We could simply do the math there. So 80 plus y equals 180. So then y here would equal 100. That's one way to look at this. So let's change colors now. Not that. Freehand text. Let's go to green. We haven't had a lot of green today. Okay. So what if we said that this side and this side are the congruent sides? If that would be the case, then y would equal z. So if we did it like this, then y would equal z. Okay? And we would still know that x is 40 because 140 plus 40 still is that linear pair. Okay? So if x is 40, okay, then we could say 40 plus y plus z equals 180. And if y equals z, then we could substitute in y for z. So we could say 40 plus y equals 180. And then just simplify. I can subtract 40 from both sides and combine those y's. So I have 2y equals 140. And then when I divide by 2, I would see that y equals 70. And we would say that y equals z, so z also equals 70. So there's a few examples for you. If I went too fast or if there's anything confusing, please go back and watch it again. Please make sure that you at least print this. I'm going to save this for you, and I will download it so that I can upload these to Canvas for you guys after you've watched this video. And hopefully y'all will be able to work on homework or in-class work depending on whether you are face-to-face or whether you are virtual. I hope you've enjoyed this, and I hope y'all have a great rest of the day.